All right, in this video, we're going to be solving a set of introductory problems to material balance from chemical engineering, all of which you can find in check. But here, I'm going to be explaining how to solve them step by step. And we're going to begin with this one, which asks us to determine the mass flow rate in kilograms per minute, given a flow of liquid toluene through a pipe at a volumetric rate of 175 meter cubic per hour. So we're going to begin with that. So for the first time of the problem, part A, which asks us to determine the mass flow rate, we're going to need to use the density of toluene. Why is that? Because we know that density is equal to mass per volume, and we can pretty much use the flow rate dots to just simplify the process. And this applies pretty much because we know that within each period of time, a certain amount of mass is flowing through the pipe, which is equal to its amount of volume, and we can use the density magnitude to convert the mass flow rate to a volumetric flow rate or vice versa. And isolating for the mass flow rate, we get that. We're going to write it over here. We get that the mass flow rate is equal to the density of the substance times its volumetric flow rate. And we're going to need to convert some units because we have the flow in hours and want it in minutes, but we get to that later. And so the step to solve this problem is just substitute the magnitudes right now because we have already the density of toluene as well as the volumetric flow rate. So we have 867 kilograms per cubic meter multiplied by 175 cubic meters per hour. What do we see here is that when we multiply these magnitudes, we're going to get an elimination of the cubic meters and we're going to get a magnitude in kilograms per hour, but we want it in kilograms per minute. So we're going to use a conversion factor, which pretty much tells us that within each hour, there are 60 minutes. That way, we're going to be able to eliminate hours. Going to be left with a product that we're going to have in kilograms per minute, whose magnitude is 2,528.75 kilograms per minute. That's how we have the answer to part A. We're going to move on to part B, which asks us to determine the molar flow rate. For that, we're going to need the molar mass of toluene. Why is that? Because we know that the formula to determine moles in a substance given its mass is the mass over the molar mass, and we can apply the flow rate to this formula as well, such that the molar flow rate is equal to the mass flow rate divided by the molar mass of the substance. And given this, we can determine the molar flow rate of toluene within the pipe. So we know already that the mass flow rate is the quantity of 2,528.75, sorry, 23.75 kilograms per minute. And we're going to divide that by its molar mass, which is 92.14 grams per mole. But we see here that there's a problem. We cannot exactly eliminate the kilograms with the grams because these are not equivalent magnitudes. We have that 1 kilogram has 1,000 grams. So what we need to do is use a conversion factor above before applying this formula. That's mainly just for aesthetics. It really doesn't mind because you know that the order doesn't really affect the product after a multiplication or division. So it's just for understanding how the process works. And we're going to need to convert the kilograms to grams using a conversion factor, which tells us that within each kilogram, there are 8,000 grams. So with that, we can eliminate the kilograms. We're going to be left with grams per minute. And once we have that, we already know the molar rate in grams per, in moles per minute. But we do not want that, right? We need the molar flow rate in moles per second. So we're also going to need to use a conversion factor. That takes us from moles per minute to moles per second. We have the minutes above, so we're going to use the conversion factors in here as well. And we know that each minute has also 60 seconds, just like that. We're going to see how these units cancel out. We have kilograms go with kilograms, grams go with grams, and minutes go with minutes. And here we have 1/second over 1/mole. So we are going to use the rule that within a fraction division, this goes with this to the numerator, moles, and this goes with this to the denominator. We're left with moles per second, which is what we're asked for. And now we're simply going to solve for the molar rate, flow rate, given the multiplication and division that we have here above. So it's going to be 2,528.75 kilograms per minute times 8,000 grams in each kilogram over 60 seconds in each minute. And finally, we're going to divide that by the molar mass in grams per mole, which gives us 457.41 moles per second flowing through.